chat.
Not keep drinking?
It's like too heavy.
No. I need, like, my body is just, like,
It's just,
I haven't been eating, so I'm, like,
you gotta eat.
wrong.
That was what helped me.
I'm gonna go sit at my little booth behind it and eat some stuff and stop
Take care.
feeling like I'm gonna die. Like,
You have to go
and
in.
I'm gonna go. You have to talk.
Okay, good afternoon everyone. Thank you for being here today. Let me welcome Clive Barron for today's talk. He is currently an IBM Cloud Architect and Zuul developer. In today's talk, we'll talk about why we chose Zuul over other technologies, what we did with it exactly, how you can do the same, and where we want to take Zuul in the future. Over to you, Clive.
All right, thank you very much. And thank you to Brno. It's a beautiful city. I've been enjoying experiencing actual snow. I'm actually from Los Angeles, so this is about as opposite as it can possibly get. So I'm really excited to talk to you guys today about Zuul and about CI and about testing and clouds and a bunch of crazy stuff. I also want this to be a two-way conversation, so feel free to interrupt me. I'll just raise your hand or shout at me, whatever it takes to get me to stop and notice you. But I'm happy to take questions while we're going. There will be some time at the end, so if you have a bigger question, you want to hold it. I promise that I will answer these questions because not everybody really will know coming into this room what I think these things are. And I actually want to know what you think some of these are too. So I will tell you what I think CI is. I'll tell you what Zuul is because that can be really confusing, especially if you Googled it and you found the Netflix project. This is not about that. And I will also explain myself and why I love pirates so much. So first, what's CI? We're not going to spend a lot of time on this because I think the industry has figured this one out, but I want to make sure we're all on the same page, right? It's basically your crash test dummies. So it's testing everything together, making sure that things that, changes that are submitted work together with all your dependencies at any given point in time. Sometimes it's pre-merge, sometimes it's post-merge. Sometimes you don't merge things until they pass CI. Sometimes you find out later that you broke the build. If I can get a show of hands, who's developed software here in the room? All right, great. And how many of you have what we would call working CI today? Good. That's great. And how many of we would like it to be better? Yes. Right? Okay, there are some satisfied CI customers here. That's great. So we wanted ours to be better in OpenStack, and so we created Zuul. When I say we, as a community, I wasn't part of what created it, but I certainly depend on it every day. So Zuul is a pipeline manager. It was developed by the OpenStack infrastructure team. If you're not, who's familiar with OpenStack? Great, good, because you're in the OpenStack track. Good job, you found us. OpenStack has 900 to 1,000 active developers at any given time. I think it's maybe over 100 active repositories. It's one of the largest single points of contribution of open source software that's ever happened. It's really been fascinating to watch the journey that it's been on. In the beginning, there was just Jenkins, right? There was one little server, and then there were 5, and there were 10, and they would just sort of run tests and hope for the best. And over time, it became clear that there was a lot of manual just messing with things to make that work. A lot of basically pulling levers. So if you were a core developer, you would be doing your code review and you'd say this needs to go, and you would have to go wait for the tests to run, and then you would say, okay, now hit the merge button. And we thought, wait, we write software, why don't we have robots do that for us? So a pipeline manager does that, and we'll get a little bit deeper into why you might want one of those. But it was made to massively scale these projects that have a really high volume and a really wide, geographically diverse team. So you don't want somebody in Shanghai to have to wait for the people in Paris to wake up and approve the patch and see that the test passed. If everything looks good and all of the I's are dotted and the T's are crossed, you want that patch to go and be merged so that everybody has it, so that everyone can rebase on it, so that we don't have collisions. So get the code well tested in as fast as possible. So why do you need a pipeline manager? Why does everybody need one? Essentially, what we want to do is replace manual landing procedures with code. Zuul is that. It's several thousand lines of Python code that has encoded the way that OpenStack works. So there's several different types of pipelines. The coolest one, which you see a diagram at the bottom, is the dependent pipeline manager, which basically says if in the process of normal code review, a core reviewer has approved, let's say, 5 patches, Zuul will go ahead and queue them up, A, B, C, D, E, and it will test them all in parallel, which is really cool. And if A and B together pass, A and B merge together, but then C doesn't pass, C, D, and E are thrown out. Now, it's actually smart enough to go ahead and just try to kick out C and try to test D and E on top of A and B again. And so that eventually it'll find the bad patch and it'll merge all the good ones, which is really important when you have 250 patches approved every day, which is what OpenStack has, all in one single integrated testing queue. Go ahead.
That's on a patch or on a patch set?
That is on a single patch. Each one of these boxes is a patch. So a patch set would be would just basically be a dependent set of boxes like this. These ones are just arbitrarily ordered this way. If they depend on each other, they're all kicked out together, right? So the patch set could be a box as well. But the important thing is that things that are independent of one another, they don't have a Git actual relationship with each other, or they haven't. You can actually make express dependencies across repos in Zuul, which is really cool. If they don't have any of those dependencies, then they can be reordered and retested in parallel. And that's one of my things, like Zuul's coolest feature is that it actually tries to look into the future in parallel. So when these are all submitted, Zuul says, okay, make a merge of just master plus A and test that. And make a merge of master plus A plus B, and so on and so on. Yes?
How do you determine what those dependencies are?
Well, if it's in a single repo, and the patches will either be based on master or they'll be based on each other. So cross repo, you can make a little annotation in the commit message and say the Garrett change ID that I need before I can actually work is here, and it'll actually combine those two in a single test run, which is really useful also for pre-merge, for even pre-review testing, because you can say, okay, there's a bug fix over here that will fix my patch. So I can say I depend on that one on this repo, and then your tests will go ahead and pass because it merges them both.
Patch level, it's not like if something didn't change over here, but is dependent on this working right for regression testing.
It is useful for that, but we're getting too. I don't have good. This needs pictures or whiteboards, right? As soon as I point 3 times, like I know I've gone off message. So we should talk more about that, and we will in Q&A. But what's really cool about this is if you have this as your queue, if you have a cloud that's big enough to run 5 tests all at once, which used to be a given, but then we started testing bare metal at once. And it's like, oh, do I have 15 bare metal servers available? Maybe not. It'll actually test them all in parallel. And if we got all greens, if A, B, C, D, and E all passed, in one testing cycle, you would merge 5 patches that were all tested and are known to be independently working, which is just really crazy good for continuous delivery, which is why we at IBM really got excited about it. And I'll talk more about that when we go into piracy. But the important thing here is that the pipeline keeps moving. And Zuul is the only thing I've worked with that's able to do this. And I think it's actually really magical that it ended up, it's like an actual open source innovation. It's not like we copied something. We didn't copy Unix, right? This is something that came out of an open source project. And I'm sure there's some hidden commercial systems out there that do it, but everybody can have this right now, in theory. But you don't yet, and I'll tell you why later. So now you know what Zuul is. And you know what CI is, so why pirates? Other than the fact that they're just amazingly cool and fun to talk about. But where this actually comes from is a group of us joined IBM to build a big OpenStack cloud. And we got there, and what we found was we expected to find IBM's sort of staunch, reputation as, we know how to deploy things. They were going to tell us how they wanted to do it, and then we were going to tell them, okay, we can adjust that. And instead, it was like nobody really knows how OpenStack works. We all know how to develop it, but how do you deploy it at scale? And so there were a lot of competing ideas, and ours was the most radical. And we were kind of just going off script completely, and every time we had a conversation, it was like, not this way, that way. And we felt like we were the pirate radio station. Like, we were the guys over here with this message that we're trying to give to everyone, but there's no official word behind it. So we got some official approval to go ahead and go down the rabbit hole a little ways, and we just called it Pirate Cloud. So from there, everything became R and Pirates and Python R. So, but it also gave us a culture. We get this little shared culture. All of our little tools have pirate names like Hoist and Mainsail. But what the idea for it was continuous delivery, and with all of the modern thinking incorporated into that. So anybody know who Jez Humble is? Right? Jez Humble is our sort of not disciple. He's our prophet. We handed out copies of the books and basically said we want to deploy continuously using all these principles that are going throughout the industry, but with OpenStack, and in a crazy way doing it by not only our changes but merging open source changes as fast as possible. So continuous delivery is, I'm a dev shop and I want to change my product fast, so I change it and I push it out. I change it and I push it out. With OpenStack, it has 250 patches a day emerging. I want to push those out, which is kind of different in that we didn't make those changes. So all we can do is fall back on our testing. If our test coverage is good, then we can trust that whatever's coming in from the community isn't breaking us because we're testing what we think works. So that was our radical idea, and off we sailed into piracy. And we immediately found that we needed Zuul on our side of the pipeline as well. So OpenStack has its Zuul, which is very mature, and I'll actually show you guys a little bit later the real-time running one. But also, we actually had a downstream Zuul. So the important thing, if you want to run a Zuul, you have to also run a Garrett. So we had the reason we chose Zuul is that we had a globally distributed team of over 70 developers, siloed between different OpenStack projects. So there was a storage team, and there's a networking team, and a kernel team. But they all had to work on one integrated queue. This sounds exactly like OpenStack. And then we also want to be able to fully test large batches of commits, but not have to wait a long time. So our testing, our full integration test end-to-end, actually deploying on real servers, on 8 real servers every time, it takes 2 hours. We can't do that in a pipeline. If people hit 5 patches in a row, we can't wait 14 hours for the one that failed and then try to reorder them. We need them all to be tested in parallel. Zuul does that. And also, just so happened that our staff was pretty heavy in OpenStack infrastructure development team members, so we actually kind of already picked Zuul. We kind of backwards justified it, to be honest. We didn't evaluate anything else. But there are trade-offs. The biggest one, Zuul, only works with Garrett. Has anybody used Garrett? Awesome. Do you guys like it? Like anybody like? Okay, yeah, right. Anybody operate a Garrett for your org? All right. Buy this man a beer. It is not easy, right? It is a big piece of software, and it's not universally popular. It is a great piece of software, but it's a big Java mess, and you have to run one. At IBM, all of these 70 developers we had were standardized on GitHub Enterprise. And at first, we tried to plug our Zuul into that. It didn't work. So we just said, you have to learn a new tool, which is Garrett. The other thing is Zuul is really hard to deploy. Even we had people on our team who had deployed Zuuls, not just for OpenStack, in other organizations. It's just hard. It was designed like organically around the Jenkins and the logging infrastructure and the clouds that OpenStack's development infrastructure had. So setting up a Zuul today is really hard. And that is a trade-off. If you need this pipeline, it's worth it. But if you don't have a clear, like, yes, I absolutely need that tomorrow, once you get into how hard it is to deploy, you're going to find that that's probably the biggest challenge. You can accept Garrett, but deploying it is hard, and that is something that the Zuul team is working on heavily right now in the V3 effort.
I would argue that there is possible to use the GitHub. We have actually developed a module for GitHub for the Zuul.
I think I'm using your patches.
Yeah, I was about to ask you, but you said that
You're gonna give away my surprise.
there was some issue with that.
It is totally possible now. When we had Pirate Cloud going, that was 6 months ago, and things move fast.
We started this contribution to upstream like a year ago.
Mm-hmm.
I think the Honza, the one
Yep.
the guy who drive this activity, and we have pretty much used it across our production repositories, and we have
It works beautifully, and we are using it.
I was just
I'm going to loop back to that. So I'm going to loop back. So this is in the past. In the past, this is a trade-off. It only works with Garrett. So that's okay. So once we got down this road, we go to our highly trained, highly skilled IBM developers who are just, they're not ready for this OpenStack world, and we found that we had just way too many knowledge gaps. We were trying to move fast. This is, maybe June of last year, and everybody we talked to had the same gaps. Nobody knew what Garrett was because they were all just finishing this DevOps transformation into GitHub. They actually didn't really know what DevOps was because does anybody know what DevOps is? Don't answer. Oh, I'm just kidding. It is tough, right? Like, I'm not always sure. But what DevOps meant to us was very different than what those developers had in their minds. And they actually weren't in a culture of code review. So anybody not using code review? Good. They were using it, but not in the way that OpenStack uses it, which is a very, very intense. There's this kind of joke, like, if you get your patch through OpenStack without any negative ones, like, your patch probably didn't matter that much. Like, realistically, everybody's got opinions, but there's also just rules, and it's important to get things right. So there was this culture of sort of like wave the patches through, and we had to reset that. And we're a distributed team. My team is all over the world. We're in Sydney, and we have people all over the U.S. And so we were like just running into this on the phone. We can't explain ourselves. So Pirate School was born. A few members of our team basically put together a curriculum and wanted to show, like, these are the important things. You need to learn the tools, like Garrett and the code review. You need to learn what gating tests are. If you haven't used gated tests, it may not make much sense. Once you have them, I actually can't live without them now. Like, I have a few projects still that don't gate, and every time it merges, I cringe, like, oh, did we break the build? It's wonderful to have a gated test where you know that master at least passed the test once, right? They also needed to learn just how to communicate with OpenStack. Because we were running continuously delivered OpenStack where we're trying to shove the community's patches through, if we needed to do a patch, it would make no sense to have our local patch sit and have to be rebased and merged and maintained. The idea was get it upstream, and then the community bases their patches on top of it. There's no more of this skew, right? We want to have as little local skew as possible. There's sometimes where you just have to. The cycle of an OpenStack patch is at minimum 2 weeks, realistically, because you got to get 2 core reviewers, and you need to attach it maybe to an artifact like a bug or a spec. we had to teach them how to do that. Create the artifact, go create a patch, engage with the community. So get on the IRC channel and talk about your patch. Go to the meeting and raise your patch's priority. All these things, and always try to fix upstream first. Even if you have to do it locally for urgency, make sure your patch is going back to upstream. And the biggest thing that we taught in Pirate School was that the people and the process matter way more than the tools. Garrett is a symptom of the process that we want, which is we want to be able to have clear communication signals, and the process that actually people have looked at your patch and that tests have run. That's more important than Garrett or Zuul or anything else. So we did a road trip. I actually attended some of them. Each member of our team, we rotated in technical experts, and then we had sort of our standard trainers. So a couple people went on all these trips. That would be Chris and Spencer. But we sent people to all the places we had teams, and they did a little class. So what did all those teams love? They loved learning practical DevOps. We used Ansible. They had never used Ansible before. They loved it. They fell in love with the idea of being able to just sort of write deployment in a sequential manner. They had been used to Chef and Puppet, and they didn't like that modeling language. They liked to be able to just say, do this, do that, do this, do that. They loved Garrett. They liked having reproducible environments. This was something that even though they had been trained on a version of DevOps, their version of DevOps didn't have the idea that your developers should work environments that are almost exactly like production, which is really critical. And once they got that, they realized that the CI system was actually even better. They could just throw patches at the CI system. Once you learn that, you realize you have a cloud behind that CI system, and your laptop becomes meaningless because you write a patch, submit it, write a patch, submit it, write a patch, submit it. And the CI system is running the tests all in parallel. And if you want to be able to debug it, you just throw something in your patch that says, don't merge me, I'm debugging. But you don't end up needing to like vagrant up unless you're at the early stages. So people really, really fell in love with that. And then because of that, that sort of reinforced writing tests. So people wrote more tests that stayed and lived longer. And that was a really positive thing. We ended up getting fewer bugs. We ended up not skewing off of upstream really at all. We had less than 500 lines of code skew at any given time. Even though we were developing features in Nova, we were developing features in Cinder. And yeah, here's just a few shots of Pirate School. I think this is from Shanghai. That's Spencer and Jamie Linux. He was our technical expert for that one. Here's the Shanghai team. Here was Beijing. We gave them pirate flags to hang in their office. So what came of this, right? We definitely had a massively improved developer velocity. People were able to get patches into OpenStack and get them out onto this cloud that we're deploying in sometimes in a matter of just a couple of days. Even though the normal cycle for an OpenStack patch could be 2 weeks, because a lot of our things that we were doing were bug fixes, they get pushed through faster and they're more obvious. So we had really high developer velocity, and that also goes for our own deployment tooling as well. When we weren't going upstream, when we were doing our own deployment tooling, which wasn't upstream, we were getting patches in just several hours. Basically, people were getting really good at changing the system fast, and then we were able to deploy. Our ops team was deploying 3 times a week, which was not as fast as we wanted to go, but that was as fast as the ops team was willing to go. We actually wanted to just deploy every day and give everybody the button. We got a bunch of feedback that people felt that they were able to communicate with teams they didn't even know before, just through patches. So we had Slack, right? We had all these communication methods, and those were great. But the team in Beijing had never met the team in Raleigh, right? They never really interacted, even though they're working on, one's the kernel team and one's the networking team. They should interact. They just hadn't really found a way to talk. You have native Chinese speakers, native English speakers. Sometimes it can be difficult, even through text. But through code, having the code review process and the inline commenting, they had never experienced that before, and they felt that that was a huge win. And they're now actually working on other projects using GitHub Enterprise, which has the same aspect, but they learned it through this, and they didn't know that was even possible. So that was a huge one. And a big thing we also got was that people learned more about what open source was. They thought it was a different license than the one you sell people. There were a lot of teams in IBM that have, they interned at IBM and then got a job at IBM and have only worked on software at IBM. And they've been using Linux, they've been using Ansible, Python, everything, but hadn't actually participated in open source communities before. And just that one step of getting a patch through into OpenStack and seeing that there were people out there who wanted to talk to them that weren't IBMers and that wanted to continue that relationship has changed things. And there are more open source projects coming out of those teams now. And they're wanting to open source things more often because they're finding, like many of us have found in open source, that it's not just the way that you work, it's kind of a way to live. There's this cultural sort of happiness that comes from it, and it does matter to people. So before I move on, I will say the project Pirate Cloud was actually put on pause, and we don't have that cloud up right now. Basically, the capital investment was moved to another part of IBM, as large corporations will do. So the end result was that we taught those teams how to work better, and we learned how to deploy OpenStack, which is still happening. But Pirate Cloud is actually shut down. So I like to say, our pirates all went and worked for the state. They're not pirates anymore, but they still remember how to be pirates. So at this point, you might be wondering how you could do that. Well, if you're a puppet shop and you want to have Zuul, the OpenStack infra team made a thing called Puppet OpenStack CI that will get a Jenkins, a Zuul 2.0, I should say. Paul, who's sitting right here, is going to talk about Zuul in more depth and the Zuul 2.5 Ansible revolution that happened recently. But Puppet OpenStack CI will set you up an older one that's more simple. It's made for people to do third-party CI. So if you want to do something behind your firewall and submit results to OpenStack patches, that's what it's made for. But we actually successfully used it to just set up a Zuul and then point it at our own Garrett. So you can do that. The thing is, it doesn't install Garrett, so you have to deal with that. And you also need an OpenStack cloud, which might be the biggest hurdle. So if you don't have access to an OpenStack cloud today and you want to have CI like I described, there are several options. You can allocate a static number of nodes to a Zuul. That is complicated and it's static, right? So you're going to have to deal with cleaning the nodes up and all the things that clouds do well. If you want to install OpenStack, there's a whole bunch of ways. There are also actually many, many OpenStack public clouds that are reasonably priced and are waiting for your elastic CI load. And I've included a link here. I know it's hard to see. If you want my slides, my email address will be at the end, and you can ask me for them. I'll gladly give them to you. And there are also managed OpenStacks if you have a really large CI need. There are some companies including my own, that will build you and host you an OpenStack cloud. So there are options for getting an OpenStack cloud. Yes?
Do you know if there are any plans to decouple it from OpenStack? So be more
There aren't, but I will say it wouldn't be that hard. So the thing that couples to OpenStack is called Node Pool. And it basically looks at what Zuul's doing and makes the cloud make that happen. So there are some hurdles to that. You need to be able to build images for whatever cloud you would be going to, and you would need to write a node pool for Amazon or for Google Cloud. But it's certainly possible. It's just that everybody who works on Zuul also works on OpenStack clouds, so we all do have OpenStack clouds. But if you don't and you wanted to, there's nothing technically in your way that's really daunting. It's just basically writing a driver. Yes. What's it? So we were running 2.0 for Pirate Cloud. So we still had Jenkins in the mix. I actually have another option if you want to do that. This is not an announcement because this isn't actually available, but my team has now moved on to making something called Bonnie CI. That's named in honor of Anne Bonny, the famous pirate. Of course, everything is pirates. But it's basically a continuous integration service we're offering to developers of open source projects on GitHub. Right now, when I say offering, we've invited two. We have very low capacity, and we're brand new. And what we have is basically a Zuul 2.5, which we're not supposed to do. So we're not doing any development or adding features to it, other than we have taken your GitHub patches, and we've actually stacked on a few. I think Jonathan Harker has been working with you guys to make Zuul 2.5 talk to GitHub. And we can do pre-approval checks, so if you submit a pull request on your project that is hooked up to this, it will run tests that you have defined in Zuul. It can also gate, so it can actually, when you say approve this and you're in the right group, it will go ahead and run your tests and then merge your code. So that right now is basically just beyond proof of concept. On the roadmap, we will have an automated sign-up. We'll have massive parallelism. Right now we have a quota of 8 nodes on a borrowed cloud, so we can't really run many tests. And we'll have all these other things which are actually part of Zuul v3, which I think Paul will talk a little more about, right, in your talk tomorrow. So go to Paul's talk more about Zuul v3. But the biggest one there is the in-repo job definition. Right now, Zuul, you have a config file for Zuul. What we want to have is in your repo, you say, like, run these tests on these triggers so that you can maintain it yourself rather than having a centralized control. And this is just a few things that are going on in Zuul v3. It's a massive refactor. It's been going on for a while. We're hoping it's done by March, but it could be later. Honestly, likely to be, but it is moving forward. So I promised to answer these. What is CI? It's necessary. What's Zuul? It's awesome. And pirates are everywhere. So thank you so much. Děkuji mi moc. And questions now? I got a question in the back. Yes.
Let's say you're using Jenkins today, and you want to consider using Zuul, and you have like 150 Jenkins plugins that do different things that are really neat. How do you even begin to consider something like Zuul?
All right, I'm going to restate the question because I just remembered I'm supposed to restate these questions. If you have a Jenkins with 150 or so Jenkins plugins, and you're using it today, and you want to have Zuul manage the pipeline, I think that's the question. How could you do that?
Could you replace Jenkins with Zuul entirely, or no?
Could you replace Jenkins with Zuul entirely? Yes. In fact, OpenStack's infra team has done that, and that is what is called Zuul 2.5. They basically just ripped Jenkins out and put Ansible in. And the only thing that Ansible couldn't do that Jenkins did was give them a web UI for watching jobs run, and they basically just made a little WebSocket thing that is running today, and I can show you in a second here. I'll tab to the status page. So the OpenStack infra team's Zuul doesn't run Jenkins, and Ansible gives you basically everything most of the Jenkins plugins that Jenkins Job Builder supports work in Ansible. So yes, you can. Would you want to? I'm not sure, but you can.
Can you keep your own existing Jenkins with 150 plugins and integrate it somehow into Zuul?
Yes, you can, but that's probably not going to be true. Just restating the question, can you keep your Jenkins and run Zuul? The Zuul v3 is a zero Jenkins refactor, and realistically, once you are free from Jenkins, I love Jenkins, by the way, respect to the developers and the community, it's an important project, but once you've outgrown it, you've outgrown it. Once you're free from Jenkins, you probably won't ever want to see it again. So, right, it can scale, but doing so is not something that I would ever want to have to do again after Infra did it.
But at the moment, like the only stuff it can run jobs on is like OpenStack, as you said. Like if you use Zuul without Jenkins, it can only run on OpenStack. You need an OpenStack.
That's true for Zuul completely. Like Zuul doesn't really work without OpenStack. Yep.
I change version on Zuul only, and the other component will be the same version, like other compatibility issues. If I, for instance, upgrade Zuul and left Node-Pool and the other, let's say, components, and they don't.
So, are there hard version dependencies between the components of a Zuul system, like Node Pool, Jenkins, Zuul? So, yes. Right now, Node Pool and Zuul are still kind of OpenStack Infra's world. So you deal with what is in those repositories, and they're not making many guarantees to users outside. There's plenty of companies that have made that work. But Node Pool has advanced now to actually be backed by Zookeeper, whereas before it was backed by Gearman, ZeroMQ, and MySQL. There's an ongoing effort to sort of move it forward for Zuul v3 that leaves the 2.0 and 2.5 users behind. But that's kind of intentional because the idea was like, hey, we never made you any guarantees anyway, so here's a tag. Good luck. So I would say it's the kind of thing, if you want to adopt today, you're going to need to be involved with Zuul development directly. If you come after v3 is ready and is being pushed out, there's going to be a willingness to make a lot more guarantees. Basically, v3 is being written so that Zuul becomes more useful to not OpenStack. So it will get easier. Right now, it's a wild and woolly place. Yes?
So all the code review and manual sign-off and patches is handled by Garrett?
Yes.
And does that also do the merging itself, and then Zuul becomes like a plus one on?
Right, so the question is, just to restate, is the code review approval process and merging handled by Garrett, which is yes, and Zuul does basically just vote. However, Zuul v3 should actually do the merging itself. So there's a problem, which is that right now the way it works is Zuul does a merge in the way that it thinks Garrett will do it, right? Because Git has several different ways to do merges. And then when everything works, it pushes the submit button via API on Garrett. And sometimes Garrett wouldn't work that well, except Zuul's gotten good at not making that mistake, I think. So it only uses the merge types that Garrett can do. But that actually breaks things. Some people will complain like, hey, no, my patch should merge just fine. Why does Zuul think it won't? You just need to use this strategy that Git would do normally. So eventually Zuul will push the patches into the repo. Right now, it hits submit. Yes?
There is an implicit assumption that the tests themselves are stable, rock solid, there are no statistical bugs and so on.
All tests are stable and rock solid.
Does that work in reality? So how are you measuring the false positives?
That the easy answer to the question, to restate it, is are there problems with tests and does that work in reality? That's development's problem, man. The reality is that OpenStack has a bunch of tools to try and find misbehaving, like racy tests that only fail 10% of the time, things like that. It's an ongoing battle. OpenStack's a massive distributed system, and testing it in isolation on clouds that are massively distributed and change, and the red car beats the blue car half the time. It's just a challenge, and Zuul doesn't fix that for you. So all integration testing runs into this at some point. Does anybody want to see the running Zuul, by the way? I can really quick pop it up. Oh yeah, we got it right there. So I just like to show this. Now, this is actually like the most busy time ever. I see policies. He's like, what's going on? This is release time. OpenStack Okata release is about to release. So there's a lot of patches that like need to land before that happens. But what you have here are 3 of the pipelines. Check is submitted patches that aren't approved, right? So those all, if you look, those are pipelines of 1, most of them, because none of them have any dependencies. So they all are just running alone. But then this nice long pipeline right here is the gate. And it usually isn't that long. But right now we have a lot of approved patches. And you see this one has been in the gate pipeline for 10 hours and 43 minutes. If you look, these are all the tests. These 2 have already passed. These ones are running. If I click through here. Oh, that's right. It doesn't have a web interface yet. You can telnet to a port and see that test's output. Or once it's finished, if I click here, I get a log.
This one is still using the Jenkins instead of the backend?
No, this is not Jenkins. So this is actually running tests via Ansible, basically. And so that's why there's no Jenkins front end anymore. And that log file hasn't been copied yet. So eventually you see there's a you can't see the URL at the bottom, but that log has been created, but it hasn't been pushed to the publicly visible log serving server yet. But you can see what's happening here is this is basically the front of the patch. So it's just testing this patch. This one is testing this one and that one, right? And so on and so on. And then you can see way down here, this one failed. So it got kicked out. It failed a test, but tests continue. So it basically, if all these pass, it'll merge to here. And then there's a new gate head right here, basically, that's testing all these behind there. And then gray ones are queued. So we're actually out of nodes, which is amazing because if you look down here at the bottom, gosh, there's a lot today. Yeah, whoa. How far does this go? This is the number of test nodes that are running right now. Looks like could go higher. Maybe there's a problem with the cloud, why it's queuing things, but sticks around 300, 400, 500 at all times running nodes. And this is across several clouds, Rackspace Cloud, the OSIC, which is like an the OpenStack, Intel, OVH, right? There's I don't even know how many there are now. But one way for your company to help OpenStack, by the way, is to donate space on your public cloud. So if you run a public cloud or know somebody who does, based on OpenStack, it helps to donate nodes. And then you can see the number of jobs launched per hour. I mean, this is a massively scalable thing. Most places aren't this massive, but we found that it worked well. Scaled down to 70 from 900. So I think it probably could even be useful for teams of 5 or 6. Just the idea of not contending on each other and not waiting to pull the lever is extremely powerful. You have another question?
Is there some logic in the scheduling? So for example, based on, without starvation, but based on the code length, on how many changes were in this area and so on, that can...
Yes, there is some logic in the scheduling. It's pretty basic, and it's not my area of expertise. So a lot of the magic, too, is actually in node pool, not in Zuul. So Zuul just kind of expresses demand. I want to run this job. And node pool looks at that demand and spins up nodes with the right image to test that. So node pool has some magic at keeping like min and max ready nodes.
No, I'm talking actually about which patch to test first in the order.
No, it's just approval order. They come in an event.
Data, you can say that smaller patch have hopefully...
No, there's nothing like that. So the way that the order is determined is there's an event stream from Garrett, and they get queued as the events dictate. So some events will lead to many, many things getting queued because at the end of a patch, everything else is approved and the last one gets approved. They all get queued in the right order. But yeah, there's no magic like that. That would be cool. Yes?
Is provisioning of instances in OpenStack part of Zuul?
Like the like provisioning and deleting of instances, that's actually node pool. You can run Zuul without node pool if you just have a static set of machines, but you have to handle the cleanup and setup of the machines yourself. But there are some like third-party places that do that. Absolutely, they've got 2 of their new model of switch, right? And a few servers hooked up to those switches physically. They don't really have a cloud there. They just want to test their Neutron driver with that switch, and so they statically have these nodes that are just available to Zuul. So basically, it's just running the launcher on those nodes, and it just pops out jobs, and then when they're done, they're done. Keeps reusing the same node.
I'm not sure if you heard about linchpin.
I have not. What is linchpin?
It's this way of provisioning instances in OpenStack and probably other areas like AWS. So I was thinking if Zuul can work with linchpin.
I will take a look at it. That's interesting.
One of the Lincoln developers has talked to the guys who are working on Zuul V3. I don't know if it's going anywhere, but there has been more conversation.
Neat. Learn something new every day. We have more time, but we can also go early. Yes?
Did you see some performance issues with Zuul or Zuul Merger that the pipeline was being slowly?
Have we seen performance issues? On the one that we ran for IBM, no. But we never pushed it anywhere near where OpenStack has pushed it. Zuul's a single process. I think it uses a couple of threads, but it's Zuul itself is, it's a single process for the scheduler, and then there are multiple processes doing merging. So that scales out naturally. You just basically can spin up more mergers, and that's the things that just pull the patches together, which is actually somewhat computationally expensive. But no, I don't think Zuul has been the bottleneck. The clouds themselves are definitely the problem. They're just, sometimes clouds go slow, sometimes clouds go away. That's, if there's one thing that leads to bad days in infra, it's a cloud storm. But Zuul itself is not doing anything really hard to scale.
Actually, we are using the Zuul 2.0, and there are some, let's say, issues with cross-repo dependency.
Yeah?
And we have to, let's say, listen on all of the, let's say, projects.
Uh-huh.
You can imagine how many projects it is. Right?
Yes.
So, and it makes the, let's say, Zuul quite slow. So we have to, let's say, listen from every, let's say, particular game.
You just reminded me. So you were saying you have seen problems with cross-repo dependencies making Zuul slow. I totally forgot about, we absolutely saw the same problem. So we were taking batches of patches from OpenStack and basically doing the one big merge commit. And in order to do that and make sure that they only all merged when they all tested, we made one big monster depends on all the other changes commit. And yeah, we would see 5 minutes for Zuul to resolve that in Garrett. Because essentially Zuul would see these, 25 depends-ons, and it would have to go query Garrett and ask for all the commit messages for that change. And then it would have dependencies, and it would have to dive down a massive dependency tree. And there was no good caching between Zuul and Garrett, so it would just sit there and basically just talk to Garrett for 5 minutes before saying, okay, yes, we're done. So yeah, we did see that one. I totally forgot it. The answer was just wait. 5 minutes wasn't all that big of a deal. So one more question. Anybody? All right, great. Well, thank you so much for your time. This has been super interesting for me. I hope it was interesting for you.
So, thank you very much. And don't forget submit a feedback for the session. Thank you.
Nice to meet you, by the way. Okay, yeah, pleasure, yes.
I was just wondering, use cases and because we are at this moment like on this 2.0.
Yes.
Integration of the Jenkins.
Yeah.
We have kind of exciting and motivating to answer what we really time.
So,
Your best
would you
bet
like
is
to
to
use
wait
VGA or HDMI?
HDMI?
It's possible.
Yeah, I mean, I'll try VGA,
Okay.
but HDMI might be better.
I believe it's
We'll see.
pretty good motivation.
I think the reason I would wait for V3 too is V3 is trying to give you a full replacement. It's not just like 2.5 was kind of in panic, trying to get rid of public Jenkins because of security problems. So it doesn't necessarily do all the things that Jenkins does. But 3 is like, hey, there's users that really need that web interface.
Yeah. So I'm just wondering what's your use case?
Well,
On top of this GitHub integration.
for us, we want to be able to basically give you a similar to Travis CI experience, but with gating and with parallelized
Hey,
testing.
Works. Is it the same as?
what's that?
It's the same.
Okay, sweet.
Yeah.
Motivation. Developers just break the bills
Yeah.
to each other and they're
We know how not to do that now. We should do that.
Yeah, and we have quite a lot of production repositories and we have combined the gating with the organic branches on the GitHub. So actually the Zuul is the only way to get
That's
the
what
code.
we're doing with Bonnie as well. And we have a little GitHub integration now called like Bonnie CI that you can install, and it'll essentially screen with you like, hey, anybody can go around.
Yes.
Our goal is to essentially.
So, we will have 20 minutes for talk, 5 minutes for Q&A.
Okay, yep,
Yeah?
yep,
We will show you the sun with 10 minutes remains, 5 and so
sure,
on.
okay. So
Just
20 for Tom.
please
Yep.
repeat each question.
Is the audio being recorded?
This is the, yes,
Okay.
this
So
is only mic
this
we
is the
have.
microphone. Got it.
They literally have to like wait for one to merge and then approve another one. But we need GitHub integration.
I was just wondering.
Yeah, we're using 2.5, not 2. And it's working fine. But we're totally not investing anything in that because any development we do is in GitHub.
Actually, we had an active development like Dribble. It took like a quarter to see this one. It was just done with my content.
Yeah.
Since the time we are not really doing any activity at all. It's simply enough for our use cases.
Yeah, one thing that's happened.
But I was just wondering that there was no activity in the upstream, so maybe it's like, okay, as you said, here's the like good luck.
It's pretty much, that's one of the reasons.
And I guess the
we're
V3,
investing.
the V3 is completely rewritten, right? They don't actually use this proposal, which was the GitHub module.
Well, so V3 doesn't include the GitHub stuff, but we are working on, like, V3 is still in such flux. We're not even trying to rebase the GitHub patches on it, but we are influencing V3 so it'll be easier to write that patch. The GitHub integration that's like this 10 patch stack, it has to dive into Zuul and change things. V3 will have, it basically has a driver interface. So you can just write an out of tree Python module that will just import and add GitHub. And hope to be able to reuse the old one as much as possible. But one thing we found, GitHub just added a whole bunch of API calls for the review system so that for specifically now you can get a webhook on approval and you can go query based on that webhook and get who approved and basically the same as the trigger modules in there. So we actually are, Bonnie